Elements in our solar system. So the life cycle of a star has many different phases, and it's kind of based on the size of the star, but they both lead to different outcomes. It starts off with the stellar nursery, which is a cluster of dust and gas left over from past supernova and planetary nebula. And the reason it's so important is because it basically has all the objects to create new stars and planets. Next comes a protostar, which is basically when a wave from a nearby explosion pushes the elements together to create a solid core and a ring of dust and gas on the outside. Then comes the main sequence star, which is about 90% of all the stars in our universe, and they typically have planets rotating around it. After comes the red giant. This is what our sun is, and at this point it depends on the size of it. The star, it could either be a red giant or a supergiant, and as a red giant, our sun's main purpose is to fuse helium into carbon and oxygen, but as it comes to the end of its life stage, it expands and then dies off, creating a planetary nebula. So a planetary nebula is an expanding shell of gas with a solid core that is left over from the red giant after it collapses. The gas and dust is pushed back into the stellar nursery, and it leaves the core to become a white dwarf. Basically, a white dwarf is the leftover core, and it has a little bit of heat, but when it runs out of heat, it becomes a black dwarf. So if our sun was 5 times larger, it would be a supergiant, and the main goal of a supergiant is to fuse elements together to create more dense elements. When a supergiant has reached iron in the periodic table, it shuts down and a supernova explosion takes place. A supernova explosion is very powerful, and in 1 second it emits the same amount of energy as our sun's entire lifetime, and this energy creates the opportunity to make more dense objects than a supergiant can. And then it leaves the leftover dust goes back to the stellar nursery, and then it either goes to becomes a neutron star or a black hole. So element locations in the solar system. Based on the gravitational pull in our solar system, the heavier elements gravitate toward the main sequence star, and the lighter elements are left on the outer atmosphere. So basically it depends on the density of the object, and based on the element of which it's created, that would change. Lastly, how are the more dense elements created? So for a red giant, its main purpose is hydrogen, to fuse hydrogen, helium, carbon, and oxygen, whereas a supergiant would fuse more elements together to create more dense objects or elements, and then a supernova provides the opportunity to make elements beyond iron. So yeah, that's about it.